Welcome to our journey into the unknown. Welcome to the new episode of Mystery Connections. Today, we're going to explore a topic that's as fascinating as it is terrifying: the end of life as we know it on Earth. As humans, we've always been intrigued by the concept of the end. Whether it's the end of a story, the end of an era, or the end of the world, it's something that captivates us, terrifies us, and inspires us. So, what would it take to wipe out life on our beautiful blue planet? Throughout this video, we'll explore some of the most plausible scenarios that could spell the end for life on Earth. From asteroid impacts to gamma ray bursts, each scenario is a chilling reminder of our place in the universe. But before we dive into the heart of darkness, let's take a moment to appreciate the miracle of life on Earth. Our planet, a tiny speck in the vast cosmos, is teeming with life. From the deepest oceans to the highest mountains, life has found a way to thrive in the most inhospitable environments. But as resilient as life is, it's also incredibly fragile. The right combination of cosmic events could wipe out life on Earth in an instant. So sit back, hold on tight, and join us as we embark on this mind-boggling journey through the potential doomsday events that could lead to the end of life on Earth. Are you ready for the final countdown? Scene script. Have you ever wondered how life on Earth could end? Let's start with the unpredictable asteroid impacts. Picture this: a city-sized asteroid hurtling towards Earth at an unimaginable speed. This is not science fiction, but a reality that occurred around 66 million years ago. An asteroid of this magnitude struck the Gulf of Mexico, and the aftermath was nothing short of catastrophic. The dinosaurs, the majestic rulers of the Earth, along with most other species of the time, were wiped out. This asteroid impact was perhaps the single most important event in human history. But why, you may ask? Simply because without it, dinosaurs might have continued to hold dominion over the Earth. Mammals, our ancestors, who were yet to evolve, might still be hiding in the shadows, cowering in the presence of these colossal creatures. Asteroids, however, are not villains in our planetary tale, but catalysts of change. They have the power to reset the evolutionary clock, opening up new opportunities for life. In the wake of the asteroid impact that ended the reign of dinosaurs, mammals found their chance to thrive. Over millions of years, they evolved, diversified, and finally, we humans emerged, the culmination of this great evolutionary journey. But let's not forget, the threat of asteroid impact is not confined to the past. Our planet orbits the Sun in a cosmic shooting gallery, a place teeming with asteroids. Most of them are harmless, but some, the city-sized ones, have the potential to cause another mass extinction. So, while we enjoy our place in the Sun, let's remember that our existence is fragile, hanging by a cosmic thread. An asteroid, hurtling through the vastness of space, could change the course of life on Earth in an instant. So, an asteroid impact, while unpredictable, has the power to change the course of life on Earth. From the unpredictable, we move to a more subtle yet catastrophic event: deoxygenation. Journey with me, if you will, nearly 2.5 billion years back in time to an era known as the Great Oxidation Event, a phenomenon that would forever change the fabric of life on our planet. This was a time when our atmosphere was filled with oxygen, a gift from an eruption of cyanobacteria, often referred to as blue-green algae. This event breathed life into our world, making it a place where multicellular life forms could thrive, where creatures like us could ultimately breathe and exist. But what if this life-sustaining oxygen were to suddenly disappear? Well, that's not as far-fetched as you might think. It has happened before. About 450 million years ago, Earth witnessed a great die-off known as the Late Ordovician Mass Extinction. This was likely caused by a sudden and dramatic drop in oxygen levels that persisted for several million years. So what could have possibly triggered such a drastic change? In the Ordovician period, our continents were one jumbled mass called Gondwana. Life was predominantly ocean-based, but plants were beginning to stake their claim on land. Then, as if the universe decided the story needed a plot twist, a sweeping climate shift occurred. The supercontinent was blanketed with glaciers, a chilling event that was enough to start an extinction-level domino effect. This climate shift and the subsequent drop in oxygen levels led to a mass extinction. It was a stark reminder of how reliant we are on this invisible gas. A sudden drop in oxygen would not only suffocate living creatures but also disrupt the delicate balance of life on Earth. It's a humbling thought, isn't it? The fact that something as simple as a decrease in oxygen levels could bring about such a catastrophic end. A sudden drop in oxygen levels, therefore, could lead to a mass extinction, wiping out most life on Earth. Now, let's look at a celestial event that could trigger a mass extinction: a gamma ray burst. A gamma ray burst, or GRB for short, is the most energetic form of light known to exist, released during a supernova or supermassive star collapse. This burst of high-frequency electromagnetic radiation is so intense that it could outshine an entire galaxy, albeit temporarily. Suppose we rewind the cosmic clock to the late Ordovician mass extinction, around 450 million years ago. The Earth experienced a sudden drop in oxygen levels that lasted for several million years. This event led to one of the greatest die-offs in our planet's history. Now, you might wonder, what could have caused such a dramatic event? In the quest for answers, the gaze of many astronomers has turned towards the skies. Over the years, a theory has emerged, suggesting that a gamma-ray burst might have been the culprit. Imagine a star, thousands of light years away, collapsing in on itself. In the process, it releases two concentrated beams of gamma radiation right out from its poles. Now, if one of those beams were to hit Earth, the consequences would be catastrophic. The burst would strip away the Earth's ozone layer, leaving life exposed to the sun's harsh ultraviolet radiation. The sudden influx of radiation could trigger chemical reactions in the atmosphere, leading to a significant drop in oxygen levels. The result? A mass extinction event similar to what we believe happened during the late Ordovician period. A gamma-ray burst hitting Earth is a rare event, but if it were to happen, it would be a doomsday scenario for most life on our planet. The cosmos is a place of beauty and wonder, but it's also a realm of unimaginable power and potential devastation. Our existence here on Earth is fragile, finely balanced on the knife edge of cosmic forces we're only beginning to understand. A gamma-ray burst, although rare, could potentially wipe out most life on Earth. Finally, let's talk about the ultimate fate of Earth, the death of our sun. In about 1 billion years, most life on Earth will face an inevitable end due to a lack of oxygen. But why would this happen? The answer lies in the heart of our solar system, the sun. You see, the sun, like all stars, has a lifespan. It's a giant nuclear reactor continuously converting hydrogen into helium at its core. This process releases vast amounts of energy, which we experience as sunlight. However, the sun's hydrogen supply is not infinite. As it burns through its nuclear fuel, it gradually changes. Fast forward 1 billion years. The sun will have exhausted a significant portion of its hydrogen. Starved for fuel, it will begin to contract under its own gravity. This contraction will cause the core to heat up, igniting a shell of hydrogen around it. The sun will then start to expand, transforming into what astronomers call a red giant. In its red giant phase, the sun will be so large that it will engulf the inner planets, including Earth. The increased solar radiation will boil our oceans, turning water into steam, which will then escape into space. This process will strip Earth of its life-sustaining oxygen. But it's not just the oxygen we'll lose. The heat will be so intense that it will vaporize everything on the surface of the planet: mountains, oceans, cities, and all forms of life. And once the sun has consumed Earth, it will continue to burn for a while longer until it finally exhausts all of its nuclear fuel. Then the sun will shed its outer layers, leaving behind a small hot core, a white dwarf. This stellar remnant will slowly cool and fade over billions of years, leaving our once vibrant solar system a dark and lifeless place. No matter how resilient life on Earth is, it cannot escape the inevitable end, the death of our sun. So, how will life on Earth end? A question that, while haunting, is also fascinating. We've explored a number of potential doomsday scenarios, each carrying its own unique blend of dread and intrigue. Let's revisit them, shall we? First, we looked at the unpredictable asteroid impact. Remember, about 66 million years ago, a city-sized asteroid struck the Gulf of Mexico, signaling the end for the dinosaurs and most other species on Earth. This event, while catastrophic, paved the way for mammals, including us humans, to thrive. Next, we delved into the oxygen crisis. Around 2.5 billion years ago, the Great Oxidation event filled our atmosphere with life-sustaining oxygen. However, a reverse event during the late Ordovician period caused a drastic drop in oxygen levels, leading to one of Earth's great die-offs. We then ventured into the realm of gamma-ray bursts. Some scientists proposed that such a burst could have triggered the global cooling event that sparked the late Ordovician mass extinction. A gamma-ray burst in our neighborhood of the galaxy would be nothing short of disastrous, bathing our planet in deadly radiation. Last but not least, we acknowledged the inevitable death of our sun. In about 1 billion years, most life on Earth will eventually perish due to a lack of oxygen. This is a scenario that, while distant, is ultimately unavoidable. These potential doomsday events serve as a reminder of our planet's fragility and the unpredictability of life. Some of these events are unforeseeable, like the sudden impact of an asteroid. Others, like the death of the sun, are inevitable outcomes of the universe's unending cycles. While we don't know exactly when or how these events will occur, what we do know is that life on Earth is resilient and has always found a way to rebound. So, while the end might be inevitable, the journey is what truly matters.